Well, hi, good morning. Thanks so much for joining me in my shop here. It's now December 29th. And first thing today was I discovered I didn't post the last video when I meant to, so I just posted it. So if you just finished watching a video on tube testing, that was actually done before Christmas, and my intention was to post it back then, but I didn't. So the result after that was an unsatisfactory operation of the radio, and the tubes can't be responsible for it. Two things happening. Seems to me two things are happening. One is the distortion I've been chasing in the audio output, and some other problem that's developed too. But one of the interesting observations I made just moments ago before I started the camera while I was cleaning up was I grabbed this little piece of porcelain I just happened to have in here for occasional use and noticed this weird bump on it. And that's wax. That's wax that dripped out of something onto it. Did it come from this radio? Did it come from a previous project? This is fairly recent. Where exactly it came from, I don't know. I don't think there's any wax capacitors in here anymore. This wasn't sitting under the radio, it was off to the side here. So something happened some time ago, I never noticed. Probably happened to, an old beater capacitor, and really doesn't matter because I've replaced it anyway. But so be it. So I think the first thing to do is to plug this radio in, make it operate, find out what it sounds like, start scratching my head about what has happened. My guess here is I've replaced the capacitor incorrectly. That's a pretty good guess. That happens in my shop. That may have happened this time. Let's find out what it sounds like here. It's been, 6 days since I've been in here? There we go. Dim bulb's behaving correctly. What I had been doing is I've been having a lot of fun on my ham radio. I've discovered a number of things. One of them is the bands, which typically you would not use, are alive and well. At least I'm using a weak signal software, FT8. Doesn't take much to get an FT8 signal detected in another radio far away. And to my surprise, even operating at 21 megahertz, I'm able to reach out right across North America on 3 or 4 watts. And I don't think the conditions have been particularly favorable for ham radio. They've been okay. It just goes to show you what these weak signal systems, weak signal software techniques like FT8 and many others can do. It's really impressive. So lots of fun there. I won't go into that any longer. If you're a ham radio operator, you know what I'm talking about. If you're not a ham radio operator and you've kind of scratched your head about, gee, should I ever get into that? The answer is a resounding yes, you should. You should. There's not a lot of money anymore. You fool around with 5 watts and a piece of junk antenna, a lousy cable feeding it, that you can get away with contacts around the world. It's great. Okay, let's see about this radio. Turn it up. Oh, that's bad, bad, bad. That is bad, bad, bad. So in my mind, that kind of sound indicates a situation where it could be something like a grid has lost its connection to anything, and it's just floated up high, very, very high impedance, because it's just a piece of wire floating in space, even though it's tucked in a radio. It becomes an antenna, and will pick up this kind of audio sound from it. So I would be suspicious something has happened in the audio circuits in this radio. One thing we can do here is I can shut down the radio by just turning this to the maximum. I think it's this way. This way. Oh my gosh, how do you like that? You know, I'm thinking of another radio. Maybe not. This is a this radio has a phono input, and I thought when you close the capacitor, it shorted itself out. Where did it all go? Oh. Seems pretty excited up here, not down here. I wonder, could it just be alignment? I sort of convinced myself this can't just be an alignment issue. The radio appears to be largely working, just very faintly. Yeah, why don't we take a look at so one likely place for that grid problem or accidental high impedance circuit is the volume control itself. If it fails to connect properly, if the slider comes off, then you've got this open wire problem in a radio like this. Even though there is a resistor from the grid, if I remember right. I don't remember right. So the grid, oh boy, that's hard to yeah, the grid is on 1 here, pin 1. It's very hard to look at this diagram here. So it's on pin 1, and there's this very large resistor connected to ground, which is to prevent exactly what I'm talking about. To prevent that kind of sound. Doesn't mean there's a problem here. It could be somewhere else. But I did change this capacitor. I don't know. What if we listen to the signal coming out of the IF? See if it's there. See if it's coming through the detector properly. And we'll do that with a signal tracer. Listen to the audio and see what we get. Sounds like a good idea. Okay, let me just turn this up a bit so I don't forget it's on. We'll use this tracer over here because it can do both RF and AF. Flip the radio up. Maybe there's wax melting out of it right now. Keep this up loud enough that I don't forget that it's on. Okay. Now, my signal tracer has a hum sound to it, which you can't hear, of course. Of course. Connect the ground to a negative. That's right, I did it in a safer way before. Do it again. Seems a little odd to me. The ground would do that. Okay. Took out some of that noise. Okay, now. So I want this tuned up at 455. It's right about there. Make sure things are done right. B, A, 455. Okay, now we want to find a good spot. I want to find say, top of the volume control would be an okay spot. Better spot is up here, but which is the pin 6 of the 12 AT6. Pin 6 of the 12 AT6. Okay. AT6, number 6. Just get a little closer look here. 1, 2, 3, 4, 5, 6. I don't think that's 6. Definitely 6 on here. 6 goes straight to ground, does it? No. What am I doing? Maybe they've grounded 6 and they're using 5. Wait a second here. The output from the IF goes to pin 6. Just a little odd. Let's take a look at pin 5. Pin 5 is the other plate. Pin 5. Pin 5 goes to ground, so it looks like they flipped around 5 and 6 is what has happened. So if we take a look at 5, the 5 is connected directly to one of the transformer pins, and there it is. So that's what they've done. They flipped 5 and 6. I guess it doesn't really make any difference to the tube or to the radio. So 5 is just probably more convenient because all he did was bend the tube terminal over to contact the terminal here, and they've soldered them together. So that's why they've used 5. It's a convenience. So we'll get on 5, and we should hear the output of the IF. Okay, pin 5. Pin 5 is just a little bit awkward here. Some brakes on my rotating table. Yeah, you think I'd have a brake set up? No, I don't. Okay. Okay. Pin number 6. Okay, I'd like to tune the radio there. Sure sounds like lots of stuff. Lots of stuff there. Okay, so the output of the IF appears to be normal. Certainly strong. For some reason we get to this tube and the story goes downhill. So let's take a look at the audio coming out at the top of the volume control. What is the volume control seeing for audio? Okay, put that to audio. Top of the volume control. So the top of the volume control is fed with a wire right from yeah, so it's this wire here. Get up on the volume control. A little tough to get up there. Otherwise, it's this terminal here. So we should get some audio here. Whoops. What did I short it against? How did that happen? There's nothing there. Why'd you make a wrong wire? First of all, I got on the wrong wire. It's over here. It's actually better place. Right here. Nothing. So I get the same result from the signal tracer that I get from the radio speaker. So the tube I stuck in there, I tested. So I've done this capacitor, this one over here. So I'm just looking for which one did I boob up, basically. Let's take a look at this one. It's off the 10 mega ohm resistor. So the 10. This guy and this one. So it comes down to a ground point. Well, it's not a ground point. Well, I'm going to stop the video for a bit. I'm going to study these capacitors right in here and just verify that I did the right thing with them before going any further. All those capacitors are in the right place. There's nothing funny going on there. I think what I want to do is just check the plate voltage on the 12AT6. It's supposed to be 55 volts, and that's on pin 7. Pin 7. Okay, that's easy to find. Here's pin 7. A little noisy. A little bit. So we're on the 150 volt scale. This is coming up to 40. And I don't have this on full. Let's get the full works here. So a little low. 40, 41, not 55. That's a little low. What would make that go low? Make that go low. That resistor there. On the other side of it, we should have 75 volts. So if I find a 220, I don't think I'm chasing the real problems with this radio, but something I've discovered anyway. Take a look at it. We would want to find the 220 coming off of pin 7. Okay, the 220 off of pin 7. So I can see a 220 going up this way, in behind the blue capacitor and goes up to the connects to this tube. Is that the same thing? Is that the other side? No. Yeah. Yes, it does. It actually does. Other side of the resistor actually goes straight to the other pin. Okay, that matches. So that's the 220. Let's take a look at the voltage. Right here. We're expecting 75. Okay, we got about 90. So it's not a lack of voltage. So just to do it again, on one side you get 90, and on the other side you get 40 something. So that resistor has probably gone high. That's not enough to shut this radio down, I don't think. 40 volts instead of 55. Considering I don't know what's going on, I think I'm going to have to deal with that situation. Which means turn it off. I'm going to have to... Did you hear that? Once again, the radio came to life at a lower voltage as the voltage went down. Some kind of a bias thing. Okay, I stay focused on what I'm looking at. So to set off this resistor, if I were to test it in circuit, capacitor there, open into the tube, other way. Well, as one side's open, that's good enough. We should be able to test that in circuit. 220. Let me get this tester here. Because it has nice little tiny clip-on leads. There might be a little bit of voltage left in the radio. Maybe I better check that. Maybe I just better check that. A little tiny bit. That might be enough to cause a problem. Just give that a moment. Might as well do the other side. Not that I should have to, but let's just see what's left in the power supply capacitors. Nothing. Nothing anywhere now. Good. Okay, do the test. Are 220K. What? Did I get the right thing done there? Is that resistor open? Let's hit it with a regular meter here. Circuit. That's my meter, I bet. Funky meter. This is a 2 megohm scale, so it should show up. That's probably it there. And everything else is probably nonsense. 300. There's 300 again. 300 instead of 220. Well, that's gone a fair bit high. That would explain the 40. It's not open though. Okay, I will attend to changing out that resistor. We'll raise the B plus on the detector tube and just see if everything works hunky-dory after that. Well, nothing like a small digression here. I'm kind of getting fed up with this meter, which has been acting up a lot from, I think, its own bad contacts in the switch, and I think maybe the battery is low in it because it misbehaves. Okay, there it is. Where's the switch? Under here. Must be these contacts here on the other side. Inside part here turns. Well, looks like I could, if I wanted to, just douse some cleaner in through these little gaps here, and hopefully it gets right up into these contacts. Could maybe just spray it through there too. Spray it in both. Spray it right down the middle here. I'm not sure about that. Don't see any other holes in there. So it looks like. Try to get it in past there. Okay, let me grab some spray. We'll use this deoxit. Hopefully the force of the spray will blow it right in there. It's pretty good force. That do anything? Who knows? I don't know. Right now I'm going to check this battery. We'll see if it's any good. 6.5. Well, that sounds, and it's just falling. So that sounds pretty weak to me. So time for a new battery. Maybe I'll make that meter work properly. What triggered this is I was trying to read the resistance of the potential replacement resistor, and I was just getting wonky numbers, just jumping all over the place. So let's see if that'll fix it. Okay, got my meter back together. I'm reading this resistor. 200. 210. It's supposed to be 220. That sounds pretty good to me. Hey, this is working nice. Look at that. Maybe I did manage to spray some of that stuff in. Very good. Excellent. Okay. Got a resistor. Gonna put it in there. Ready to solder in one lead here. Maybe while I do that, I'll give you my quick update on the COVID situation here in Canada. It's bad. That's the simplest way of putting it. We're watching the levels of the virus just explode. Everything is being strained. Testing, hospitals, not quite yet, but I think that's coming for sure. People here are quite cautious. Certainly where I live, the area of Canada I live in, we've been wearing masks 100% of the time when we're out in public and stores and things like that since the start of the mask wearing way back when. In fact, it's just so normalized now. It's nothing to put a mask on. Christmas period, we were warned strongly about getting together. I think a lot of people made the same decision that we made here. We changed our plans. We had a couple visitors here, my family, my immediate family. We did the COVID quick test thing, and we're all boosted except for one of us. One of us is not boosted yet, so we're a little anxious about that. That'll be corrected in just a few days. That person will get boosted, and the word is we're all going to get this, boosted or not. It's a question of how sick you're going to get from it. So if we're boosted, we won't get so seriously ill, or maybe not really ill at all, just like a cold or something like that. But if you're not vaccinated, that would be about, I don't know what the numbers are now, but it'd be something like 15% of the population above 5 years old. Something like that is not vaccinated here in Canada. It's a regional thing. Depends where you are. And again, I think I've mentioned before, Canadians are fairly compliant with the government and the authorities in the government, the public service authorities. I mean, they all say the same thing. There's no particular conflict. Some political leaders are scared to bring down the hammer again. So they're pussyfooting around. I think we all see it here. People are, there's restrictions on gatherings, various kinds of restrictions. Depends where you are, again, what province and the like. But some groups are just voluntarily shutting themselves down. Some restaurants and that are just giving up. The problem is, of course, the staff are getting sick, and the staff are off for the duration of the isolation period, and there's just not enough people left. And I think this is a big sort of knock-on effect, of course, of this, is even if you're not going to end up in the hospital, even if it is just a bad cold or a flu-like illness that you can weather and get over, you can't be at work. And those numbers, I think, are going to get very large. I think we're a couple weeks behind the UK, and I think the United States is a couple weeks behind us, I think. So we had 27,000 cases yesterday. So you multiply that by 10, that's 270,000. Multiplying it by 10, you're sort of normalizing it with the American population. And they're right around there. They're right around the same amount, the same per capita type amount. But I think we're farther along. So I think the Americans are going to shoot through the roof. I hate to say comical. It's not comical, but it's, people are talking about the situation today, and they're not facing up to what is coming in the next week or two or three. That's what it seems like. Yeah, certainly in the United States, I'm referring to here again. Very compliant population, and I don't mean compliant in a stupid way. I mean, I think just everybody agrees with what the experts are saying. As much as you don't want to, but what you want means nothing. Means nothing at all. So that's the battle here. I've got the resistor in. I think we're time to test it. I don't think this is going to improve the situation with the radio. Well, there's really only one way to find out. Let's switch it on. I'm going to want to measure the voltage. So let me get ready for that. Here we are. And which pin was it? It's measuring. This is on the detector tube. And pin 7. Pin 7 should have 55 volts on it. Okay, ready now. Plug it in. Okay, and just one last look. Switch on. In the meantime, I pulled that tube out and tested it again on my tube tester. It tests fine. Certainly the triode tests just fine. One of the two diodes tests a little low, but still in the passing range. I'd say lower than the other. One test lower than the other. What do we got happening here? Wow, that's a great improvement. What's happened? There's no, the output tube is half out of its socket. I must have knocked it loose. Cut the power. Okay, let's try again. Well, we certainly seem to be going in the wrong direction with this radio. Now I tuned it up towards the other end of the band. It seemed to have a lot more signal. Oh boy, I've really done it in. Oh, there it is. Almost no volume. Okay. Sounds like it's still warming up a bit. And the voltage now is, watching the meter over here, that's on the 150 volt scale, so we're looking at 55 volts, somewhere in this range here. 90. wrong side of it, wrong side of that resistor. 90. How did that happen? How did that happen? How did that happen? Let me just check here, make sure I'm doing the right thing. That's the sort of the input side. This is the output side. Oh my gosh. It's supposed to be 55 and it's 90. It's like there's no tube current. No current in the resistor. Again, one side. Okay, and the other side. Oh, it's exactly the same. The resistor failed to make a connection? Well, it couldn't. If it didn't make a connection, I wouldn't get a voltage on the other side. Not necessarily true. If it didn't make a connection down here. Look at that. I really did a nice job on it. Thought I did a nice job on it. Well, sure looks soldered. That's not soldered. Things are going downhill. I'm sure that's soldered in there. Let's try this. Take this. Touch this to the terminal. I put the totally wrong size. No. 200K. Looks more like did I put the wrong size resistor in there? Come on. Really? Is that what happened? Didn't I test it? Didn't I test the stupid thing? Didn't I? Son of a gun. I think I booped that all up. Ah. Yeah, it looks like I put in the wrong size resistor there. The brown band looks yellow to me, but it's not. It's a brown band of one. Duh. I guess I didn't test it. And after I fixed my... oh, this is going to be a hassle. Okay, hassle. I will hassle away with this. Okay, doesn't that look like a yellow band there? Yeah, but no. Here's a good one. Supposed to be 220. 219 will do. Fantastic. Now I got the right kind of resistor. Hey, let's see what kind of mistake I can make now. I'm sure I can come up with one. Okay, now I have the correct size resistor in there. Let's see what happens. Basically today I was intent on searching for a mistake, and while I'm searching for a mistake, well, I really haven't been searching for a mistake. I got hung up on doing this resistor and made another mistake. Man, I am the king of mistakes, no doubt about it. Here we go. Not plugged in. Here we go again. There goes the dim lights. Okay, voltmeter test. Still on the 150 volt scale, so we're looking at something coming up about here. Okay, supply side of the resistor. Nothing. resistor. There we are. This takes a while. 90 volts. Other side. 52. Okay, we're cooking with gas now. Did that help at all? Good. We're back to the same bad operation that was here at the start. Volume's almost full to get that. Okay, well, I think that's it for today. I don't think I really got anywhere. Well, I did correct the plate voltage on the detector. Didn't make any difference, though, did it? But that may have affected the distortion if we could only hear some. But we won't. Weak radio. Okay, that's tomorrow's deal. Weak radio. Wait a minute, let's do this. Let's do this. Do this. Turn it back on. We can do a simple test here. I'm just going to lower the supply voltage slowly. And we'll just see what happens here. Here we go. Sixty-seven volts. Let's go up a little bit. I think the heaters lost their heat. That's what happened there. But for sure, when I first turned it down, radio's receiving better. Gotta be like a biasing thing. Okay, stick it back up. Okay, that's okay. How many okays do you want to say before you say farewell? Have a great day, and tomorrow I will attempt once again. Attempt something. See ya.